Capacitors. A capacitor consists of two conducting plates separated by an insulator. Here we have a simple diagram showing the two capacitor plates, both initially with zero overall charge. They have the same number of positive as negative charges. When connected to a power supply by closing the switch, the charges will move briefly as shown. So the negative charges are going to move round from the left-hand plate to the right-hand plate. Soon, the potential difference across the capacitor will equal that of the supply, and so no further charges can move. The greater the potential difference, the more charge will be stored, although strictly speaking, as you'll see, it is simply a rearrangement of charge rather than any extra charge being stored. Plotting a graph of charge against potential difference for a capacitor gives a straight line through the origin, something like this. This shows us that the charge is directly proportional to the potential difference applied. Double the potential difference, we get double the charge stored. So we can write that Q is directly proportional to V. Q for the charge, V for the potential difference. The constant of proportionality depends on the capacitor itself, and this is known as the capacitance of the capacitor. And this is given the symbol capital C. So we get that C, the capacitance, is equal to the charge Q in coulombs over the potential difference V in volts. The capacitance is defined, therefore, as the charge in coulombs that is needed to raise the potential difference across the capacitor by 1 volt. Capacitance is given the symbol capital C and is measured in farads, symbol capital F. You have to be careful not to confuse the capital C for capacitance, a property, with the capital C for coulombs, the unit of charge. Let's just run through a simple example. A capacitor is connected to a 3 volt supply and found to store 1.5 millicoulombs of charge. Find the capacitance of the capacitor. Well, using capacitance is charge over potential difference. Putting in the values, 1.5 millicoulombs over 3 volts gives a capacitance of 5.0 times 10 to the minus 4 farads. Often capacitances are quoted in microfarads, so we could write this as 500 microfarads.